Good morning, students. Today we will discuss concept of continuity part 2. In the previous lecture, we have studied that the continuity of a function at a point. Now today we will discuss the continuity of a function in an interval. So definition of such type of functions in which interval is given to you, that is, a function is said to be a continuous function if Yes, a function is said to be a continuous function if and only if it is continuous at every point of its domain. Domain means set of all points where function is continuous. Domain of continuity. In particular, if the domain is a closed interval, say that is closed interval from A to B, then f must be continuous in open interval AB and right continuous at A and left continuous at B. It means what? When you are talking about the continuity of a function in an interval, closed interval, function should be continuous at A, at B, and in between the points of A and B. Now let's take an example. Let function fx is given to you, that is 3x minus 2 when x is less than equal to 1, and it is 3x minus 4 when x is greater than 1. In the previous lecture, it was given to you that to check the continuity of function at 1. Now here it is written that is it continuous, and justify your answer. No point is given to you. It means you have to check the function for all real numbers. It means domain of the function is all real numbers. Therefore, we have to examine function for continuity at all x which belongs to real numbers, capital R. Okay. Now 3 cases will be there. Let's discuss. Let C be any real number. 3 cases arises. 3 cases arises. First case when C is less than 1. As it is written in the previous slide, the function is, function for the number line. Suppose number line is this one. It is 0, or here it is 1. Suppose it is 1. Here is 0 somewhere. And for less than 1, it means for less than 1 numbers, function will be 3x minus 2. If it is greater than, this is for less than 1. And for equal to 1 also, it is 3x minus 2. When x is greater than 1, the function you have to take, that is 3x minus 4. Okay. Now in the first case, I have written here, C is less than 1. Any number which is C that is less than 1. It means function you have to take, that is 3x minus 2. If C is less than 1, the value of C will be equal to 3C minus 2. 3C minus 2. When you are applying the limit on this function, it means you are getting limit x tends to C, 3x minus 2, we are getting 3C minus 2, that is equal to same as function at C. So what function is continuous? When you are taking C is less than 1. When C is greater than 1, when C is greater than 1, here I have written function is, you are taking 3x minus 4. It means what? F of C will be equal to 3C minus 4. And when you are applying limit on the function 3x minus 4 extending towards to C, then you are getting 3C minus 4. Both are equal. It means what? Function is continuous. Both values are same. 3C minus 4 and function at C. It means function is continuous at C greater than 1. When you are taking any number which is greater than 1, then function is continuous. Now third case is if C is equal to 1. This is the case which we have discussed in previous lecture. At a point, it means C is equal to 1. At a point means you have to check continuity of function at 1. At 1, function will be, it is written to you, function will be equal to, here it is written 3x minus 2, put the value of x here 1, you're getting 1. It means f of 1 will be equal to 1. Now check what is the left limit and what is the right limit. Here you have to check what is the left limit, what is the right limit. Left limit function is 3x minus 2. It is already told you. Put the value of 1 here and you're getting 1. Function is continuous at x is equal to 1 from the left hand side. When you put from right hand side, that will be 3x minus 4 function. Put the value of 1 here. We are getting 3 minus 4, that is minus 1. Function is not continuous at x is equal to 1 from the right hand side. So what? Function is discontinuous at x is equal to 1 but continuous at all the other points. So the continuity domain is real numbers minus 1 because 1 is the point where function is discontinuous. Now for the next further. Here is a question. If the function is given to you, fx is equal to mod x upon x when x is not equal to 0 and it is 0 when x is equal to 0. Show that function is continuous everywhere except x is equal to 0. Now what is important in this question? You have to frame the question by splitting the mod x. Now, as you know, in the previous class, you have studied that. What is the mod x? Mod x is what? Mod x is equal to x if x is greater than equal to 0. It is minus x if x is less than 0. Now here I have separated the function. When I am taking x greater than 0, I have to put mod x will be x. I have put here x. X upon s, it comes out to 1. It means if x is greater than 0, then the value of y is 1. If x is less than 1, you have to put minus x. It means minus x upon x, it comes out equal to minus 1. So when x is less than 0, it is minus 1. Y is equal to minus 1, you can say. And x is equal to 0, then y is equal to 0. It is given. It is given. It is written here. So new function becomes, after simplification, this is fx is equal to 1 when x greater than 0. It is minus 1 if x is less than 0. It is 0 when x is equal to 0. So the domain of the function is all real numbers. Now you have to check the continuity of the function for all real numbers. For all real numbers. But 3 cases will be there now. Again, first when c is less than 0, because 0 is the point which is the which gives you what left and right both. You have to check c whether c less than 0, greater than 0. In both cases, function is continuous or not continuous, as we discussed in the previous question. C is less than 0 means what? Less than 0, you can see here the value of y is minus 1. When c is less than 0, it means what? X less than 0 means any number c which is what? Less than 0, you will get y is equal to minus 1. It is written here. If you have to check the limit of the function, then again you are getting limit x tends to c, that is minus 1. On minus 1, there is no x, no change in the constant function, only you will get the value as it is, minus 1, and it is equal to f of c. It is what function is continuous at when or you are taking c less than 0. Same as c greater than 0, f of c is 1, and the limit when you apply, you are getting 1. Both are same, then function is continuous when c is greater than 0. Now at 0, you can check it from this here. At 0, it means what at 0? When you are taking, yes, here, suppose number line is, this one is the number line. This is 0. If you want to check the continuity at 0, it means you have to go very near to 0 from the right hand side and very near from the left hand side. It means what? When x is greater than 0, the value is 1. X is less than 0, the value of y will be minus 1. Both are approaching to the different numbers. So what? And the value at 0, f of 0, it is given 0. All three are not equal. What it implies? The function is discontinuous at x is equal to 0, and it is continuous other than all the points of x is equal to 0, other than all x is equal to 0, except 0, all the points function is continuous. Only at 0 it is discontinuous. It is written as it is in there, and this is a non-removable discontinuity. Now next question is, it's a very good question. Examine the continuity of the function on greatest integer function. Greatest integer function fx is equal to greatest integer function x, and domain of the function is all real numbers. I'm talking about domain of function and domain of continuity. These are two different things. Domain of the function means for which values function is defined, and for which values function is continuous, it is a domain of the continuity. Now here two cases will be there. In the case of greatest integer function, first case is when the c is belonging to integers. Let's take it integer. Suppose c is an integer, then f of c will be equal to c. As you know that, if I explain again the greatest integer function, for the meaning of greatest integer function, if in 11th class you have studied about this function, suppose greatest integer 2 is written, it means value is 2. If greatest integer 2.1, then the value will be what? 2.1 is lying between integers 2 and 3. The answer will be 2. If you are finding greatest integer of 1.9, 1.9 is lying between 0 and 1 and 2. 1 and 2, it means value will be 1. Smallest integer will be the value. So here is what, if you are taking any c, suppose c is on number line, suppose c is this one. When you are approaching from right hand side, the value of this will be what? C is lying between the integer c and c plus 1. C and c plus 1. If c is an integer and you are approaching towards c from right hand side, it means c and next integer will be c plus 1. The value will be what? C. Smallest one integer will be c. If you are taking and you are approaching towards c from left hand side, it means c and this is c minus 1. The very near value to c from the left is lying between the integers c minus 1 and c, and smallest one is the answer. It means what? The value will be c minus 1. Both are not same. Left and right, both left and right, both limits are not same. That's why function is discontinuous when you are taking any integer. In the case of integer, when you are taking any integer, the function is discontinuous. Now other than integer, if you take the value, what will be the result? Let's see. Yes, if c is not an integer, when you are tending towards that number from left and right, you are getting the same number c. Greatest integer c. F of c is greatest integer c, and greatest integer of x extending towards to c is also the greatest integer c. The same both cases we are getting the same value. It means function will be continuous. I will explain it like this. Suppose you are taking any number which is not integer, Suppose you are taking 1.5. When you are tending from right hand side to the 1.5 and you are tending from the left hand side, what is the value? 1.5 in both cases. Greatest integer of this is 1.5 is lying greater than equal to 1, less than 2. So what? It is always equal to 1. If it is suppose 2.2, 2.2 again from when tending towards to 2.2 from left and from right, we are always getting the value 2. So what? Left and right both limits are uh, uh, coming same, and the value at that point is also same. The function is continuous. So domain of the continuity will be real numbers minus integers. Real numbers minus integers. Here it is written real number minus integers. Now here for properties and theorems of continuity regarding continuity of the function. Theorem first is what? Just read it. Let f and g be two functions continuous at x is equal to c, then if f and g are two continuous functions, then the following will be true also. Alpha times of function is continuous at x is equal to c for all alpha belongs to real number. Alpha is any scalar quantity. The difference of the function is continuous at x is equal to c. Sum of the function is continuous at x is equal to c, and product of the functions also continuous at c. Quotient of the function is continuous at x is equal to c, but here you have to remember denominator should not be equal to 0. Theorem number second regarding domain of the functions. Let d1, d2 be the domain of the continuity of for the functions f and g respectively. Then alpha times of f is continuous in the domain d1. D1 is the domain of f. Then alpha times f function also having the domain d1 for all alpha belongs to real numbers. F and g having d1, d2 domain, then difference, sum and product of the functions are continuous in the domain of the intersection of these two domains d1 and d2. Quotient is also continuous. D1 intersection D2 is a domain of the function f upon g, where g should not be equal to 0. Domain should not be equal to 0. A polynomial function is continuous function. Next theorem. Rational number function is continuous at every point. F is continuous at c. Then mod of function is also continuous. If function is continuous, then modulus of that function is also continuous at the same point. For example, if x is continuous, then modulus of x is also continuous function. All algebraic trigonometric functions are continuous. All algebraic inverse trigonometric functions are continuous at every point of their respective domain of the definition. Now, here's the example. Prove that function fx is continuous. As I have told you, trigonometric functions are continuous. Apply the theorem, this one. All basic trigonometric functions are continuous. If trigonometric function, this inside function is continuous, then this modulus values also gives function which is continuous. How to write it? Cos x is continuous for all x belongs to R. Mod of cos x is continuous by using the theorem. 5 told you. It means what? Modulus of function, modulus of cos x is continuous function. Now fx is equal to modulus of 1 minus x plus mod x. Show that it is continuous. Now split this function into two parts, 1 minus x and mod x. First function is 1 minus x and second function will be mod x. 1 minus x means function is a polynomial function. I've told you polynomial function is always continuous function. And this is mod x, modulus function is continuous function. And addition of these two functions, if f is continuous, g is continuous, then their sum is also continuous. I have told you in the theorem. Here function g and h, the sum of their function is also a continuous function. If this function is continuous, then modulus of this function will also be continuous. Then take the mod 1 minus x plus mod x of absolute mod of the function will be continuous function. Suppose next theorem, suppose f and g are real valued functions such that f of g is defined at c if g is continuous at c, and if f is continuous at g of c, then f of g is a composite function. This is a continuous at x is equal to c. Apply this theorem on the question. Suppose function is given fx is equal to cos x square. Split this function into two functions. That suppose hx is equal to cos x and gx is equal to gx is equal to gx is equal to x square. Now find out composite function h of g. We are getting h of gx means put the value of x in h. X will be as gx. What is gx? That is x square. So h of x square you have to calculate. That comes out cos of x square. H and g are continuous functions. Why these are continuous? H is a trigonometric function, g is the polynomial. Both are continuous function. So what? Their composite function is also a continuous function. H of g will also be a continuous function. So what? Given function f is continuous. This is a very good question. That is the last question of the exercise. In this question, find all the points of discontinuity of f defined by fx is equal to mod x minus mod x plus 1. This is the function which is having the difference of two functions. First function is mod x, second is mod of x plus 1. You have to apply the theorem here. Take mod of x as first function and mod of x plus 1 as a second function. Prove that both functions are continuous. Then difference of these function will also be continuous. So this approach will be applied on this question. Let's see what is the procedure to do the question. Let f be the combined function of mod x and mod x plus 1. Gx is, suppose mod x is gx and mod of x plus 1 is the hx. I think I have told you how to prove by taking cases. If g and h are the continuous function, then f will be continuous because f is equal to g minus h. Now our target is to what? To prove that g and h are continuous function. Now to show g is continuous, first of all, split the mod function x when x greater than equal to 0 and minus x when x is less than 0. Let k be any real number. Now I have told you how to do the question in the previous questions, taking three cases. C is any real number. Here I have taken k as a real number, and you have to take three cases: k less than 0, k is equal to 0, k greater than 0. For all three cases, you have to prove that a function is continuous function. When you will take k less than 0, then you have to take minus x function. If k is equal to 0, you will take x, y is equal to x. And for k greater than 0, again you have to take the y is equal to x. Now you can do for that case 1, k less than 0. I have proved here that all values are minus k. And g is continuous. K greater than 1, greater than 0. Again g is continuous because you are getting k value both sides. And when k is equal to 0, again you are getting same value 0, 0, and but you are getting function is continuous at x is equal to 0 also. Less than 0, greater than 0, and at 0. And next function, which is hx. Mod of x plus 1 can be split as like this. X plus 1 equal to 0 means x is equal to minus 1. Minus 1 is a turning point where the function changes the nature. So what? When x is less than minus 1, then function will be minus of x plus 1. If x is greater than equal to minus 1, then y will be equal to x plus 1. Now again you have to take three cases. K less than minus 1, k is equal to minus 1, k greater than minus 1. You have to check the continuity of the function at when x less than minus 1. You have to take the function y is equal to minus of k plus 1. And when k is equal to minus 1, you are taking k x plus 1. If k is greater than minus 1, you have to take the function y is equal to x plus 1. Now prove it here on now. Function becomes continuous at h. At the place of when here you will prove at 1, then you have to prove 1 left, 1 right. And from right when you are approaching towards 1, and from left when you are approaching towards 1. Both cases you have to solve. We have discussed all these things in 11th class also, left and right limits. Now h is continuous at x is equal to minus 1. Now we have proved h and g both are continuous function. So what f is a function which is the difference of these two functions. So what fx is equal to gx minus hx is also a continuous function, and no point of continuity discontinuity will be there. As function is continuous everywhere, no point of discontinuity will be there. Now complete the exercise 5.1. Both cases we have discussed: a point, a continuity at a point, continuity in the interval, and continuity of the composite functions we have discussed. These are the topics which are in your syllabus. Now complete the exercise 5.1. Thank you. Have a nice day.